Hello, calculus. Okay, fundamental theorem of calculus, part 2. There are 2 steps. Okay, the first step is you plug in your limit for t. The second step is you multiply everything by the derivative of that limit. Okay, so the limit that you're plugging in is the limit that is a variable. All right, so let's keep that clear right here. Your limit has to be a variable. Okay, so when do we use the fundamental theorem of calculus? It is when we are taking the derivative. That's what d dx stands for. That means derivative. Alrighty, you're taking the derivative of an integral. All right, so that right there is an integral, and that is your first clue that you should use the fundamental theorem of calculus part 2 when you're taking the derivative of an integral. Okay, so the first step is we take that limit that is a variable right here and we plug it in everywhere we see t. So that's our first step. We have x squared minus 4x plus 3. All right, the second step is you multiply everything by the derivative of that limit. The derivative of x is simply 1. Alrighty, so that answer is just equal to x squared minus 4x plus 3. And there you go, final answer. Yippee! Okay, so that one wasn't too bad. Great shortcut, huh? Okay, let's keep going. All right, B, again, we're taking the derivative of an integral. Fundamental theorem of calculus, part 2. So the first thing we do is we take that limit and we plug it in everywhere that we see t. So that's our first step. So we're going to get, oh, we got to plug it in here too. Hello, there's a t right here. Okay, so on top we get x. On the bottom we get x squared plus 4. And that is the first step. The second step is we multiply everything by the derivative of this, and that, of course, the derivative of x is just 1. So our answer there is just x over x squared plus 4. Again, another quick, easy shortcut. Okay, moving right along. We're going to C. Okay, now again, we're taking the derivative of an integral. That's your tip-off. Fundamental theorem of calculus part 2. But now you notice that your variable limit is on the bottom. So your limits are flipped. So we use the property reversal of limits. If your limits are flipped, you just change the sign of your answer. So we're going to plug in, we're going to do the same 2 steps. We're going to plug in x everywhere we see t. So that gives us the sign of x. Now we have to multiply everything by the derivative of that limit. So that's just times 1. And we have to remember to make it negative because your limits are flipped. All right? So you have to change the sign. All right? So our final best answer here is just negative sign of x. All right, so be on the lookout for flipped limits. All right, on to D. Onward. Okay. Alrighty, now here we have a derivative of an integral, fundamental theorem of calculus part 2. So we take that first step, we plug in that limit that has a variable in it for t. That is our first step. So we get the sign of x squared. All right, now the second step. We multiply everything by the derivative of that limit. So the derivative of that limit, the derivative of x squared, is 2x. All right, so now to write out our answer, we need to put that number, that coefficient out front. So I'm going to write it as 2x times the sine of x squared. All right, there we go. So there is that final best answer. Alrighty, let's keep going. A, B, C, D, E. All right, it's late at night. Forgive me. Okay, now we have another twist. This is new. We're still taking the derivative of an integral. So that is still Fundamental Theorem of Calculus Part 2. But now you notice that we have a variable in our upper limit and we have a variable in our lower limit. So here's what we do. We simply do the shortcut. Oops, highlighter mode. We do the shortcut twice. Okay? We do the upper limit minus the lower limit. All right? So the upper limit shortcut minus the lower limit shortcut. Okay, so let's go to work. The first thing we're going to do is we're going to take that upper limit and we are going to plug it in for t. So that gives us the cosine of x to the fourth. All right, now we have to multiply everything by the derivative of that limit. The derivative of x to the fourth is 4x to the third. So I'm going to put that right out here, 4x to the third. So there is the shortcut for the upper limit. All right, and now we go again. Now we do the shortcut for the lower limit. So the first step, we plug in that limit everywhere we see t. So we get the cosine of 5x. All right, and the second step tells me to multiply everything by the derivative of that limit. The derivative of 5x is 5. I'm going to put that right there. So there it is. There is my answer. So we just do the shortcut twice. There we go. I love to highlight. All right, gives you time to catch up, right? Okay, so again, there's the shortcut for the upper limit. And here is the shortcut for the lower limit. That's what you do if you have a variable in both limits. All right, let's do F. Same thing. Okay, we have a variable here in the lower limit and a variable here. So we do the shortcut twice. Okay, first shortcut. We take 3x squared and we plug it in for t. So we rewrite the entire function. 1 over t, which is now going to be 3x squared plus 5. All right? And then we multiply everything by the derivative of that upper limit. The derivative of this is 6x. So now because that's a fraction right here, I'm going to make 6x a fraction. I'm going to put that over 1. So there is the first two steps for the upper limit. All right? So now we go to the lower limit, minus. All right, now we're going to plug in this everywhere we see t. So now we rewrite the function 1 over, but instead of t, we put in x, 1 over x plus 5. And we multiply everything by the derivative of this limit. The derivative of x is just 1. All right, so now when we simplify here, we're just going to multiply tops and bottoms. On top we have 6x over 3x squared plus 5. And over here we just have 1 over x plus 5. So there we go. There's your final answer. Got to highlight. Oops, not erase. Oh man, it's late. Okay, you get the idea. Highlight. Okay, let's keep going to number 2. Number 2, it's just going backwards, okay? It asks us to find the derivative. Alrighty, so what are we going to put here? This tells us to take the derivative. I'm going to highlight that. We're taking the derivative of an integral. So that right there tells you fundamental theorem of calculus. So you're not doing anything different. The directions are written differently. I want you to be able to recognize when you use the fundamental theorem of calculus part 2. It's when you see a derivative, you take the derivative of an integral. All right, so first step, we plug that upper limit in for t, and we get 5x squared. We multiply everything by the derivative of that. That is just times 1. So our answer is 5x squared. There we go. Okay. And then finally, part B. Same thing here. Fundamental theorem of calculus part 2. We're taking the derivative right here. Where's my directions? Right here. We're taking the derivative of that integral. Okay, so this goes quick. We take that upper limit, first step. We take that upper limit, we plug it in for t. So the tangent of x cubed. That's the first step. The second step is we multiply everything by the derivative of that. The derivative of x cubed is 3x squared. Those are your 2 steps. Now to simplify it, that coefficient should absolutely go out front. So 3x squared, tangent of x cubed. And there you have it. That's Fundamental Theorem of Calculus Part 2. All right. We will talk. See you later, Calculus.